Hello, this is Basnak Ota from the University of Edinburgh. Today I'm going to talk about a topic that I've been working on in the past few years. It's collaborative work with a number of people whose names will be mentioned in the relevant parts. So the starting point of this research is the question of why the world's languages exhibit some properties and not others, or more broadly, why some properties are more common than others. And in phonology, for example, there are patterns like the ones on the left column here, which are typologically more common in comparison to those on the right column. In particular, I'm focusing on the typological asymmetry shown in the last two rows. That is, vowel harmony is widely attested, but vowel disharmony is rare. And in contrast, consonant disharmony on major place is a common phenomenon, but major place consonant harmony is not. A possible explanation for this that has been addressed a lot in the literature is what is known as substantive induction bias. The idea is that as learners, our mental hypothesis space is restricted to induce only certain types of generalizations, in particular those that are phonetically motivated. So given a lexicon with vowel agreement, you might be able to learn a phonological grammar of vowel harmony, but given a lexicon with vowel disagreement, you're not going to learn a grammar of vowel disharmony. This idea has been tested in many studies using an artificial language learning paradigm, but the results are somewhat mixed. So some studies show that it's easier to learn long-distance dependency between vowels than between consonants, and that vowel harmony is easier to learn than vowel disharmony. But other studies have shown that vowel disharmony is as learnable as vowel harmony, and as far as I know, no studies have demonstrated that consonant disharmony is easier to learn than consonant harmony. But that's not the only possible way that learning can shape phonological systems. An alternative scenario is that we are better at learning words with a certain structure, say words that contain similar or identical vowels. This type of bias, which we can call form learning bias, is not going to have any immediate effects on phonology. But if you allow for the possibility that it cumulatively affects the lexicon that's learned across generations, then you can see how this might lead to the typological skews that we find. Over time, the lexicon becomes populated with more words containing similar or identical vowels. And a generalization made over this lexicon is essentially vowel harmony. So is there evidence for this type of form learning biases? Well, not so much. There are a few infant studies showing that words containing similar vowels or identical consonants and vowels are better segmented, and words with repeated consonants and vowels are better learned. But these findings don't give us enough to differentiate form learning biases for consonants as opposed to vowels. So one of the things that we did was to test whether there are form learning biases for words that are consonant harmonic or disharmonic, and words that are vowel harmonic or disharmonic. We did this by comparing how well participants can learn labels for unfamiliar objects, depending on the harmony profile of the nonwords. And we had three types of words. One type was like kika, which had identical consonants but dissimilar vowels. A second type was like tumu, which had identical vowels but dissimilar consonants. And the last type was like meku, which had dissimilar consonants and vowels. In one study that I did with Aitor San Jose and Kenny Smith, we tested this with orthographic words. And in another study that I've just finished with Joe Basnak, we used spoken words. And here I'm going to present the spoken word version, but the orthographic word version worked in very similar ways. So in the spoken word version, the stimuli were created by synthesizing non-words with Spanish sounds, but using only segments that corresponded to sounds in English. As I already mentioned, the critical items were CV-CV words of 3 types. The one had identical consonants, so we call this C-rap. Another had identical vowels, or V-rap. And the last one had no identical segments, and it was called no-rap. When the segments were not identical, they were made to differ maximally. But the 3 types of words were controlled for things like word likeness, phonotactic probabilities, and neighborhood density. And we also had some fillers too. We had monolingual speakers of English learn these words, and the results are shown in the figure there. The dependent variable was the Levenshtein edit distance between the correct target and the form that was recalled by our participants. So the lower the bar is, the more accurate the learning was. As you can see, they learned C-rep words like Kika better than V-rep or no-rep words such as Tumu and Meku. We got the same results from the other study that was done with orthographic words. So what this means is that there is a mismatch between form learning biases and typological patterns. Our participants learned the typologically dispreferred forms with identical consonants better than the typologically preferred forms with different consonants. And we didn't find any advantage in learning the typologically preferred forms with identical vowels compared to forms with dissimilar vowels. So this is a bit of a mystery. If form learning biases can affect the shape of lexicons over time, why don't we say phonological systems preferring consonant harmony? The explanation may be that because consonants play a larger role in maintaining lexical contrasts than vowels, and because consonant repetitions restrict lexical contrasts, they are dispreferred from the perspective of language use or communicative effectiveness. And this type of pressure counteracts the learning bias for consonant repetitions depending on how much pressure to learn is imposed on the system. And testing this idea was the purpose of the main experiment in the Ota, San Jose, and Smith study. In other words, we wanted to test whether form learning bias affects the harmonic structure of the emerging lexicon through transmission, and whether the outcome is modulated by the relative pressure for learning as opposed to language use. We used a modified iterated learning paradigm in this study. There were 2 phases in the experiment. In the first phase, the participants independently learned the non-words as labels for unfamiliar objects. And in the second phase, the participants engaged in an interactive game in pairs. And in this, one person will announce the label of an object that only they could see, and the other person had to choose the object that matched that label. They were given points for getting a match, and they took turns. Now, the critical manipulation was between what we call chains and closed groups. In a chain, the first pair learned the object-word mappings and played the interactive game. The final labels they used for the objects were then passed on to the next pair, who learned those mappings and then played the game. This process was repeated 5 times, or over 5 generations. In a closed group, however, there was only one pair of participants, and after they learned the mappings, they kept playing the interactive game for 5 rounds. And we had 12 chains and 12 closed groups. The stimuli were orthographic words, and we made them by randomly concatenating CV combinations, which were also randomly generated from a set of consonants and vowels. We created 6 languages with a lexicon of 12 words and 6 languages with a larger lexicon of 18 words. And half the chains and closed groups were assigned to the small lexicon, and the others were assigned to the large lexicon. And here's what happened. The proportion of words with consonant repetition increased in the chains, but the increase was suppressed in the closed groups. You can see this from the solid line that shows the chains and the dotted line that shows the closed groups. Now, there wasn't a statistically significant difference between the two lexicons of different sizes, but there was some indication that consonant repetitions increased more in the small lexicon, suggesting that lexical contrast is one of the factors that counteracts with consonant identity. Surprisingly, vowel repetitions followed the same pattern, so they increased in the chains but not in the closed groups. This was despite not seeing evidence that our participants were more accurate in learning words with vowel repetitions. So this means there are 2 different types of form learning bias. One that comes from faithful retention of the target forms, which seems to be the source of consonant repetitions, and one that comes from a biased innovation in unfaithfully copied forms, which seems to be the source of vowel repetitions. So, in summary, these experiments show that form learning biases exist, and they can affect phonological systems that emerge through cumulative transmission. But whether the effects are seen in emerging systems depends on the interaction between pressures from learning and language use. More generally, these findings show that a comprehensive understanding of the role of learning in phonology must include consideration of form learning biases as well as induction biases. So thanks for listening. If you are interested in reading more about this research, one of the studies that I talked about today is already published in the journal Cognition, and the full reference is shown here. Alternatively, you can send me an email at this address.